Greetings! I was watching Queso Fuego's video on writing your own boot sector using flat assembler. It reminded me of some of the old assembly programs I wrote back in school. So I decided maybe I'd take one of those and try to port it so that I could kick it off in bochs, because a lot of those are designed to run under DOS. That's, becoming more and more difficult to access. So I'm going to try that. We're going to take this tail part of his assembler file here. Actually, not even that much. Just his boot sector magic, which just puts a magic number in 511th and 512th byte of an image, and then we can have a program like bochs load it directly, right? Let me show you the program we're going to be... So I have this dice roller program that I made in school. It was used to roll dice for role-playing games like D&D and such. So let me show you real quick what that looked like. So I have a bochs instance set up to boot into DOS here. This is just booting into FreeDOS, and I still had the COM files that I originally assembled with the A86 assembler here. So we got this one dice. If we sit here and we roll, I don't know, let's say 10 die 100. So I hit 7 10 times. Net total. We had 434, so it was a little low that time. But that's random, so, well, it's pseudo-random. So we'll get runs like that. Let's try dice 6s. That one actually came out high. So let's clear that, and we can quit it. But it's a very simple program. You could probably write this in the language like C or Java in like 10 minutes. But the thing is, I want to try to port an assembly language program from one assembler to another and make it so it can boot straight into it. So like, once again, right here we're inside of a DOS environment, so I could make it do DOS things. That pong.com there is another file. Obviously that runs like I can just barely move. But that's a problem for another day. Let's keep going on this DOS one. So what we're going to do is I have this directory here, which we're going to do our work in. So let's start by copying the dice program over. We'll bring that over, and that's it for now. So we got the instructions for the flat assembler here, if we need to reference that. We got our BIOS calls, because those are going to probably come up. And I'll probably have to Google some assembly instructions, because, it's been a while, we'll say. Okay, so this is the original 86 one. Let's open... Okay, so this is just a copy of that one, so we can actually close this one just so we keep confusion down. So if you look through this program, there are some issues that we come to light if we're going to port it. So first we look at the interrupts it calls. And so interrupts are, these are software interrupts because we're triggering them from software. These ones that start with 1, or like 1A, 10, 16 hex, are all BIOS interrupts, or probably all BIOS interrupts. We'll see if we encounter a problem. The ones that start with 2 are all DOS interrupts. This one here that prints a line is int 21. Int 20 is the one that ends the program. Now, we don't have to worry about ending the program because the program's not going to end. What we'll probably do is maybe either replace this with a jump back to start, or maybe we could put an endless loop there where it literally just sits there and does nothing. But we'll figure that out later. And then we have, so we're going to have to write a routine to print. Now, on the topic of writing routines, there's only one function called in here. It's called twice. It's called write. It's, was this IO function that I got from somewhere. I mean, I may have written this back then. It's not particularly complex. But the big thing is it writes the outputs of the contents of the CX register. Now, if you'll look, though, when we look at the ints, it calls exclusively int 21. So it's basically just doing some divide by tens and then calling int 21. We are going to want to rewrite this anyway. So we got to write a write function. We have to replace these calls to int 21, which is basically another write function. And then we need to figure out any changes that... So this was written for an assembler, the A86 assembler, which, if you look at this, if you're familiar with assembler... Why is it saying SM6502? If you're familiar with assembler, you're not going to look at this and be like, oh, this is completely alien. It's mostly the same. I'm sure that probably uses different codes for some of these constants and stuff. But we'll figure that all out, and we'll change this to be compatible with the flat assembler. So I kind of want to start, though, by creating a simple Git repo so that I can look at what changes I made from the original program to the final program. So what we'll do is we'll come here and we'll just do Git Init. So now it's a Git repo. So this file is obviously copied from a DOS disk at some point. So you see that it has execute permissions, which it doesn't need, and it currently doesn't have write permissions. That's no good. So I'm going to change this to user plus write. Oops. Right, and everyone's going to lose execute on it, because now if we get an ls of it, you see, okay, now I can rewrite it and other people can read it, which is just fine. So now we have that, so let's add it to our Git repo, git add, then git commit. So we're just going to put a comment here, initial assembly program imported from old A86 archive. So now if we make changes, we can see what we've changed, which I find useful. And it's also just, good to track these sorts of things. We could just try running it under assembling it. Let's see what happens. FASM, process move, error, invalid operand. Move is invalid, which seems, maybe it's seed. So what this instruction here is trying to do is move the DX register into this seed, which is a word we've allocated down here. So probably this needs to be colons down here. So that it can recognize these symbols. And then it probably doesn't want, let's leave the W on there and see if it still doesn't like that. Because this is a word, and we'll see what that does. Still doesn't like it. Okay, well, we hit a sticking point already. So this probably has to do with the way literals are defined, and we'll figure that out. Let me just real quick go into what this first part of the program does, as you might be able to tell from the what this first three instructions does is it moves 0, 0 into the upper half of the AX register. So that sets the first byte to 0, and then we call int 1a, and then we move what's in the DX register into the seed, into this memory location seed. And as it says here, we're seeding the random number with a timer. So just to review that, if we go to 1A, and we look at 1A00, it tells us that it reads the real-time clock. That doesn't spell it out, so let's see if we can get a little more detail on that one. Just so for this guy. Here's a better description. So you can see here on entry, if AH is set to 0, then it's going to do this. It's going to put into DX the lower part of the clock count. So this is going to be the part that's changing faster. This is just your standard initialize your random number generator with the clock. Being that we're going to be running on an emulated machine, this might actually result in us getting this might not be a very sufficient form of randomness, but we'll see. The emulator box does use the real-time clock based off of the local time, so there's a reasonable chance that this will work. And the big thing here, though, is this is the lower order part, so this should change far more rapidly than this upper part. If you look here, CX is what they call clock. So CX and DX are clock together, and when you look all the way down, this goes down to something in the order of hundredths of a second, but obviously it isn't the hundredths of a second because that is multiply here. So it's probably like 18ths of a second, which is, if you're going to be, even if you were like manually spamming a key, you're probably not going to hit the same key on 2 of those. And mean that we only sample this once at startup. More than enough randomness for our purposes, provided it counts from some, not just the emulator starting. Let's look up what the syntax is in flat assembler for specifying a variable. So this supports namespaces of symbols, which might be a good way to clean up some of the symbol mess this program has. Now, admittedly, we don't need that because we're going to be doing stuff fairly simple. You know what? Yeah, this boot sector code. I'm sure he has driving them here, which he must use somewhere in here. In square brackets with a type before it. Oh, so that's our first lesson in flat assembly. So if I say word seed, let's see if that solves the problem. If we get past that line now. We do. Okay. Next time we'll finish getting this program cleanly assembling. Feel free to subscribe or come back here often to not miss that next video. Or come follow me over on GitHub. Have fun out there. Happy hacking.